This is a more realistic application of the equilibrium constant K. It shows when we know a numerical value for K, we can determine equilibrium concentration of reactants or products. So the question is asking us to calculate the equilibrium concentration of F2, in this case a reactant, and we're given a value of K. We start by writing our equilibrium constant expression. Here's our equilibrium constant expression. We have a concentration of our products raised to its coefficient divided by reactants raised to their coefficients. What the question is asking us for is to determine the equilibrium concentration of F2. So our first step is to solve this expression for F2. Our first step in solving for F2 is we'll cross multiply. This times this is equal to this times this. All right, now remember what we're solving for, we want to solve for is the concentration of F2. So we're going to get F2 raised to the fifth power by itself on one side of the equation. So what we're going to do is to divide both sides of the equation by K times the equilibrium concentration of Br2. Because what that does is that it cancels K, it also cancels Br2. So we've solved our expression for the equilibrium concentration of F2 raised to the fifth power. But what we really want is just the equilibrium concentration of F2. So this is how we're going to solve for the equilibrium concentration of F2. We know what F2 to the fifth is, so to find F2, we just take our expression of F2 to the fifth and raise that to the 1/5 power. This is very similar to solving for x if you're given the value of x squared. X is going to be equal to the square root of x squared. So again, what we're trying to do is to solve for the equilibrium concentration of F2. What we've generated, and I've kept it here in blue, is an expression of equilibrium concentration of F2 raised to the fifth power. So we take the fifth root of this expression and we're going to get the equilibrium concentration of F2. So all I've done here is to reproduce the expression from the previous page. Now I'll go back to this question statement and input the numerical values. And this is what the solution looks like. I input the numerical values from the original question statement and put these numbers in my calculator and get this result. Now I'm going to raise this result to the 1/5 power. Now when you do this on your calculator, make sure that you include these parentheses. So you have this value in your display and you're going to raise that to the 1/5 power. And this is the numerical answer we get, and with the appropriate number of sig figs, which is 2, we get our final answer. Alternatively, we can solve this question using the decimal equivalent that 0.2 is equal to 1/5. This makes inputting this into our calculator a little bit easier. We don't have to worry about including these parentheses. So you have the same number and you're going to raise that to the 0.2 power and we get the same numerical result.